Shapes of galaxies. Galaxies are commonly classified according to four main shapes: spiral, barred spiral, elliptical, and irregular. Spiral and barred spiral galaxies. About 77% of the observed galaxies in the universe are spiral galaxies. Our own galaxy, the Milky Way, is a typical spiral galaxy. Spiral galaxies are named for the spiral-shaped arms that radiate out from the galaxy center. So you can see the arms radiating out from the sides. About half of all spiral galaxies, including the Milky Way, have what appears to be a bar across them. These are called barred spiral galaxies. You can see the bar near the bulge or the core of the galaxy. A typical spiral galaxy completes a full rotation once about every 300 million years. From the side, a spiral galaxy looks like a thin disk, as you can see from this shape. The disk is difficult to see through because of all the dust and gases between the stars. It is in these dusty regions that new stars form. The disk of a spiral galaxy is not completely flat. Near the core is a widening called the central bulge. It consists mainly of very old stars. New stars rarely form here because of the lack of dust and gases between the stars. Spiral galaxies are further classified by how tightly their spiral arms are wound. A galaxy with very tightly wound arms, such as the right galaxy in the list above, would be called Type A galaxies. As you can see, all the arms are tightly wound. A Type B galaxy has more loosely wound arms. This galaxy has more loosely wound arms than Type A, and Type C galaxies has the most loosely wound arms. The arms of spiral galaxies have lots of gas and dust, and they are often areas where new stars are constantly forming. The bulge of a spiral galaxy is composed primarily of old red stars. Very little star formation goes on in the bulge. Elliptical galaxies. An ellipsoid is a shape like a flattened sphere. Elliptical galaxies range in shape from almost perfect spheres to flattened globes. As you can see in this picture, this galaxy looks like an almost perfect sphere. Such galaxies are thought to result when other galaxies such as spiral galaxies merge. The largest galaxies in the universe are elliptical. The light from an elliptical galaxy is brightest in the center and gradually becomes fainter toward its outer regions. As far as astronomers can determine, elliptical galaxies rotate much more slowly than spiral galaxies, or not at all. Elliptical galaxies have much less dust and gas than spiral galaxies have, and few new stars appear to be forming in them. Elliptical galaxies contain very little dust. This means they have fewer young stars than spiral galaxies do. Irregular galaxies. An irregular galaxy is a galaxy that does not have a regular shape like a spiral or elliptical galaxy, as you can see in this picture. Irregular galaxies are usually found in groups or clusters. The distorted form of an irregular galaxy may result because the galaxy collided with another one or got close enough that the gravitational force from the other galaxy drew stars away. Irregular galaxies are denoted by the letters IRR. Irregular galaxies are classified in two ways, IRR1 and IRR2. The irregular one has young stars, gases, and dust, while an irregular 2 looks as if other galaxies have collided together. Dark matter. Celestial objects in space add up to less than 10% of the total matter in space. The remaining 90% of the universe may be filled with the matter that is not even visible. This is known to astronomers as dark matter. Dark matter refers to the matter in the universe that is invisible because it does not interact with light or any kind of radiation. Now, as you can see in this picture, the dark blue ring that is inside of the blue is what we call dark matter. Black holes. Through studies of hundreds of thousands of galaxies, astronomers believe that each galaxy contains at least one black hole in each galaxy. A black hole is a section of space where gravity is so strong that nothing, not even light, can escape. The gravity in a black hole is very powerful, strong enough to pull in a star. The more a black hole takes in, the brighter it grows. So as you can see in this picture, this is the black hole, and as time passes by, it grows larger and larger and consumes everything in its path, from stars and planets to any other celestial objects in its area.
Light is affected by many factors, including the gravity of supergalaxies, and can even be reversed and swallowed by the massive gravitational sucking power of a black hole, never to be seen again. The incredible mass of objects described as black holes have a gravity so strong that it sucks in all surrounding substances, including gases, stars, galaxies, and the light from 1,000,000 stars. If light and time were synonymous, or even remotely related, this would mean that time flows backwards when in the grip of a black hole. Black holes come in all sizes, with supermassive black holes having such incredible gravitational pull that they can suck in and devour other stars and even galaxies. However, black holes are not destructive per se, but appear to play a truly central role in the formation and maintenance of galaxies. In the center of many galaxies lurks a black hole, including in the center of our own Milky Way. Black holes may be essential for galaxy formation, locking billions of stars together, which dance and swirl together round and round a black hole, which locks them in its grip.
Star clusters. Galaxies also contain distinct groupings of stars known as star clusters. A star cluster is an assemblage of stars in a relatively small region of space. Star clusters occur in two broad types: open cluster and globular cluster. Open cluster contains a few hundred to a few thousand stars. They are among the youngest star groups in the galaxy. So as you can see in this picture, there are hundreds of thousands of stars, and all the stars are widely spaced because the gravitational force is not strong enough to pull all the stars together. Globular cluster contains hundreds of thousands of stars drawn together in a spherical form by the star's gravity. The globular clusters are the oldest star groups in a galaxy. In contradictory to the open cluster, globular clusters have enough gravitational force to force all the stars in to make a small group. Galaxy clusters. The Milky Way is a part of a group of about 20 galaxies. Such a group is called a galaxy cluster, and the one containing the Milky Way is known as the local group. More than 2,000 billion stars lie inside this cluster. We live in Earth, which is in the solar system, which resides in the Milky Way. The Milky Way resides in the local group, which resides in the local cluster, which resides in the local supercluster. The local superclusters and all superclusters reside in the universe, which is the largest amount of space or area.
Okay, I have a class to teach now, Jomar. Good luck on your test.
Okay, thanks a lot, Mr. K.